Here we go. We have a question, zero array transformation part 2. So you are given an integer array and a 2D array queries where ith element in the query contains three values L, R and value, where ith query in the queries array represents the following action. We can decrement the value at each index in the range of L to R in nums by at most value given in the queries I. The amount by which each element is decremented can be chosen independently for each index. A zero array is an array with all its elements equal to 0, and we need to convert the nums array, which is the given array, we need to convert this nums array into zero array, and we need to find out the minimum possible value of k such that after processing the first k queries in sequential order, nums become zero array. If no such k exists, we need to return -1. So suppose we have given this, and first query is this. So it means in the range of 0 to 2, so 0, 1, 2, between this to this range, this is our range, we can decrement at most 1. So we have given this array, and after applying this operation, my nums will look like this. And after applying the second operation, which means from 0 to 2, we can decrement at most 1. So my array will become 0 array, right? So therefore the minimum value of k is 2. So we can convert nums array into 0 array after applying 2 operations, right? So the output is 2. We need to figure out the minimum value of k. And suppose we have given this array, and in this array we can convert between 1 to 3. 1 to 3 is our range. We can convert all the values by at most 2, right? So after converting this, my nums will look like this. And after applying the second operation, which means 0 to 2, we can decrement at most 1. So my nums will look like this, but still this is not a zero array, and I have applied all the operations, still it is not possible. So if nums cannot convert into zero array, we need to return -1, means it is not possible. Now let's build the approach. Suppose I have given array which is like this, right? And my query will look like, so let's say I have given queries 1 to 2 at most 3, and 2 to 5 by at most 1, 0 to 0 at most so let's say 14, right? And so then let's say 0, 1, 2, 3, 4, 5, 6, 0 to 6, let's say 5 times, and 0 to 5, let's say 4 times, and 1 to 6, let's say 8 times. So suppose I have given this type of something. So we can apply first operation. So after applying first operation between this to this range, I can decrement a value by at most 3, and I can do this on every index individually. So this value will become 0, and then I have given 2 to 1, 2 to 5, 2 to 5 at most I can do 1 time, so this will become this, right? After applying 0 to 0, my array will look like this. Then 0 to 6, I can decrement by 5 times, so 2, then 5, then 2, then this. So you got the idea that we need to figure out the minimum index of k. After that my nums will become 0. So isn't this isn't this equal to is this similar to binary search? Why binary search? Because suppose this is my given index, and after applying this much operations, so to prove it, just to prove it, let me write 50 here. Okay, so after applying four operations, right, after applying four operation, my nums will become 0 array, right? So we need to figure out this index, and after that I can apply at any number of operation, still my nums will become 0 array, right? So after applying this, it is not possible, this not possible, this not possible. After applying this is possible, my nums will become 0 array. So I will apply binary search here. My L is here, my R is here, then I will find my mid element. So L is equal to 0, R is equal to query length minus 1, right? So my R is equal to 0, 1. So let me change the color. 0, 1, 2, 3, 4, 5, right? So let me do it like this. My L is 0, my R is 5, then its mid is this. So after applying mid number of operation, but still can I apply each operation individually, which means I have to iterate 1 to 2, I have to iterate 2 to 5, then I have to iterate for 0 to 0, right? Still it is taking time, but can we do better? Yes, we can do better. Instead of converting this array, I will create a separate array. So let's say my temp array of the same length. What is its length? Its length is 7. So 0, 0, 0. So 0, 1. 2, 3, 4, 5, 6. Yes. So then I will apply prefix sum here. How? So it means 1 to 2. Between 1 to 2, I have to add at most 3. So let me take the upper bound only. So 3 will be here, and till here to here, I have to add 3. But after that, 3 will be subtracted. So let me write minus 3 here. So I am applying pre-computation, which is prefix sum. Then we have 2 to 5. So 2 to 5, we have to add 1. So 2 to 5, 5 is here. So till here to here we need to add 1. On the sixth index, I will add minus 1, right? Then 0 to 0, it means on this index I have to add 14. So 14 will be here, and here to here 14, but here the value will be minus 14. So minus 14, and it will be minus 11. So then I have added, so on my queue I have three things: L, R and value. What I am doing, L plus equal to value and temp R plus 1 minus value. It means L to R we need to add value, and R plus 1th value will be decremented, right? So then I did this operation, but I still need to calculate. I still need to find the prefix array. So let me find the prefix array. The value here is 14. Then 14 minus 11. 14 minus 11 is 3 only. Right. So then 3 plus 1, 4. 4 minus 3, which is 1. Then 1 here, 1 here. 1, 1. 1, 1. Then here 0. So it means on first iteration I did this. On the second iteration, I did temp of I plus equal to temp of I minus 1, which is previous index, right? Isn't this equal to this? Let's verify. From index 1 to 2, I have to add 3. So 3 is added. From 2 to 5, I need to add ones. From 0 to 0 I need to add 14. Yes, it is equal. It is equal. Then we need to figure out, is this value greater than, is this value greater than this value? It means we can achieve 4 also, because we can apply on every index, we can apply the value individually. Yes, if this value is greater than, means this index can be made. Then this index is also greater than this value, this index can also be made. Index 2 is also greater than, index 3 is not greater than. It means we need more such operation on index number 3, right? We need more such operation. It means till mid it is not possible, we need to add more such operation. So to add more such operation, we need to move right hand side. So my L, mid is not possible, I am pretty sure mid is not possible. Then my L is here, which is 3, right? Till mid the answer is not possible, so we need to apply more such operation. Then I am on the right hand side, then this will be my mid, then this will be my mid. So we need to apply this much operations, right? So then again create the temporary array. So let me again create the temporary array. Temporary array 0 0 0 0 0 0 and 0. So first operation is this, which is from 1 to 2 we need to add 3. From 1 on index 1 add 3, on index r plus 1 write minus 3. Then it means 2 to 5. From 2 to 5 I need to add 1. So 1 is here, and on the 6th index the value is minus 1. Then the next operation is 0 to 0. So 14 is added here, and on the next index or r plus 1th index the value is minus 14, but 3 is already there, so value is minus 11, right? So the next operation is 0 to 6. From index 0 to 6, so this is crucial part, from index 0 to 6 I need to add 50. So 50 is added here, so 64, and 50 is subtracted here. So I need one more index to be careful that we don't go out of bound. So we need one more index. My temporary size is n plus 1 only. So it means on index 6 plus 1, from 0 to 6 I need to add 50. On the next index we need to add minus 50. We need to add minus 50. Then the next operation is 0 to 5. 0 to 5 I need to add 4. So 4 is added here, and 4 is subtracted here. So minus 4. Okay. So I have added mid number of operations. So the next iteration is to find the prefix. Okay. So this plus previous. So this plus previous will be 57. This plus previous, which is equal to 58. Then this plus previous is equal to 55. This plus previous 55. Then this plus previous is equal to 55. This plus previous, which is equal to 50. So we have 50 here. Then this plus previous, which is equal to 45. Okay, so we did two operations. First is this, which is to apply mid number of operations. Then the second iteration is to find prefix. Then the third iteration will be to check that our temporary is greater than or equal to nums. Okay, so this is our third iteration. Index 0 can be made, index 1 can be made, index 2 can be made, index 3 can be made, index 4 can be made, index 5 can be made, index 6 can be made, means index 6 value is greater than or equal to nums value. So I am pretty sure that till mid number of operation I can make my make my input array to 0 array. Yes, so mid will be my valid answer, or the answer is less than or equal to mid. So let's reinitialize our R to mid, means mid is our valid answer. So what is this? So this is 4. So then I will again find, and this will be my mid, and this mid is enough to make my array to 0 array. Then my R is again is equal to 3. My L and R is equal to 3. It means my answer is 3. It means 3 is a valid answer. It means my answer is equal to 3. I will return 3 in this case. Okay, so let's code this. So first thing, we have L and R. So L and R. Then L is less than or equal to R. Find the mid and apply mid number of operations. So after applying mid number of operations, if mid number of operation can we achieve nums? So let's check. So I have a separate function name apply. So this is my apply, and I have given q, which is number of queries, and k, which means the number of operations we are allowed to do, and nums. Then we have temporary array of n plus 1. I will apply k number of operation, L, R and value, figure out L and R and value from the query. Then add on the lth index and subtract on the r plus 1th index. So after doing this iteration, the next iteration is to find prefix array. Then the next iteration is to check if our temporary is less than, it means we cannot make. If all values greater than or equal to, it means we can make. So the answer is true. If this is true, if mid value is true, it means we can make nums array to 0 array after applying mid number of operation, or the answer is less than or equal to mid. So R will be reinitialized to mid, or the answer is less than, right? Else, we have else condition. After applying mid number of operation, we cannot make nums array to 0 array. So we need more such operation. So my L is equal to mid plus 1. At the end, just return the L. But we can optimize this. How we can optimize this? So we can write a separate condition, which is to check after applying all the operation. If still after applying all the R operations, R is the query length, still we cannot make nums array to 0 array. So I have a separate condition in the if statement. If apply all the operations, still we cannot make, it means I have getting false. So we cannot make, we don't need to run this while loop, we can directly return -1. So that's how this approach will work. Let's submit this. And yes, it is working fine. Then let's discuss about the time and space complexity. So we have this nums array, we have this queries array. So let's say my nums array length is n, my queries array length is m. So I'm doing this. So this is log m, right? This is log m, and apply. In the apply, I have k, which is k only. So the k is our mid. So in the worst case, it can go till r, right? It can go till the length. So length is m, let's say, right? So this is m, n plus n. So let me write it here. So first we have a while block, and so while block will run till log of m, and inside this while block I have apply function. So apply function has 3 iteration. First iteration in the worst case can go till m. Next iteration is order of n only. Next iteration is order of n only. So inside of this I am doing these 3 operations. So it will be log m multiply, so log m multiply m plus n, right? So this is my time complexity. What about space complexity? For space I am just using this temporary array. So it is it is order of n. That's all about this question. Thank you all for watching.